video where we're going to be proceeding with TypeScript. In the previous video, we covered TypeScript inference, so how we can define types of our variables. So we talked about variable initialization, where we are able to assign a value to a variable having defined it. So we discovered that TypeScript infers its type based on the values type. For example, this price variable, we were able to discover that price is inferred as a number. For the string, we're able to discover that name is inferred as a string, and you can easily use it. By the way, it's not even a must to describe. You can also do it like this in the normal script, and it works still. We went on and talked about the functions. So we talked about the default parameter values in the functions. We said that the type of the function parameter with a default value is also inferred based on the type is value type. And also talked about the function return type, this one, and we discovered that TypeScript attempts to infer it based on the return statement within the function. So TypeScript can check and know what is supposed to return. We also talked about the array. Here we discovered that the inferred type of the arrays can reflect the type of the elements and the properties. So we were able to define the type of array and use it as we defined it. So in today's video, we are going to talk about a few things. We are going to talk about enum in TypeScript, object type, any type. Then we shall see how any versus unknown. Then we shall also talk about TypeScript aliases. We shall also talk about TypeScript interfaces. We shall also discover the difference between type and interfaces. We shall also talk about TypeScript casting, TypeScript guards, the basic generics, the utility types. So subscribe to my YouTube channel, JordanCarlzen, and follow for more content about web development. So let's get into discovering what enum is and how we can apply it in our apps. So let's talk about enums. Now enums are simply let me say they're used to define a set of named constant value that make your code more readable, maintainable, and type safe. Maybe to show you a use case of enums, you can use them to represent status codes in an application such as HTTP status codes or custom statuses. So let me illustrate this with code. So I can say enum I call it status. So this is its syntax. Status as pending, followed by in progress, followed by completed, so I'll come here and say that let current status status. So I'm giving this, I'm defining of type status and status dot pending. So you can see I can access pending. Sorry. So here I can access all my statuses. So I can initialize the current status to be pending. Sorry, something I removed. Yeah, select. So I can access pending. So I can go on and write an if statement, and I say if current status is equal to status dot pending, you go console log task is still pending. Yeah, task is still pending. So we can go to our browser, inside our console. Let's refresh. So you can see that we have this task is still pending and it's coming from the server. So that's simply how Enum works. You can also use it for other stuff. You can use it for role management. Let's say you are defining roles in an application, such as user roles in authentication systems. You can make use of Enums. You can also use it in configuration options. That is when you want to represent configuration settings or modes in your application. You can make use of enums. You can also use it in flags and bitewise operations. You can define a flag value for the bitewise operations, such as function, file permissions. They can all be done by enum. So error handling, the error codes like 404, 494 are forbidden. You can do all that with enums. So that was that for enums. So our next part is object type. So let's get into object type and understand what it's about. So for object type, here the use of object type is simply to represent a collection of key value pairs where keys are strings and the values can be of any type. So the use case is simply to model complex data structures and real-world entities. The objects, they have no slight difference with the arrays. So let's see how the syntax looks like. I can have a const of car, and I have my object as a car. Then I can define the objects that are going to be in this car. So I will have the type of the car, which will be a string. We'll also can also have the price of the car, which will be a number. Which will be a number. Then I can also have the and of the brand and mode. Let me say, let me use, let me just say the year of manufacture, manufacture. Manufacture. So manufacture will also be, will also be a number. So I've defined the types of the object that I'm expecting. So I'll go on and initialize the object. So I will pass in the key that I defined above. So this will be type. So since I defined type as a string, so expect me to write a string here. So let me say Toyota. It is the type of the car. The price, let me say it's of $3,000. Finally, the year of manufacture, let me say it was manufactured in 2002. All. So that's how we simply define the types of the object. So this is the basic structure, but you can still do it this way. You can here and say type, and you say car props. You go on and sing this very same thing here. You have all this type. So when you come at this object where you want to, so I have this. Let me call it my car. So it is my car. can define it from here that Micah is going to take in the capprops. So inside here, they expect me to have type. I can call this type. I can call it Isuzu. Then the price to be $10,000. Then the year of manufacture to be 2022. Yeah, so this is another way how we can define the types of our objects. So you can do it this way. The benefit of this, you can export these types. You can use them to some other projects, to some other objects. Unlike this one, where you define the types once and use it only on this object. So all these two cases can apply in different situations. So that's all for objects. Let's jump to the any type, and we discover what any type is. So this is the any type. The any type, I simply let me say a use case where you don't want to define the types. Let me say that default to a type. You don't want to specify a type. So TypeScript can allow you to do that. A type to be any. So this simply means writing in basic JavaScript. So the any type in TypeScript is a workaround for the case when you don't know what the type of the value might be. So let's illustrate how this can be done in the actual code. So I can have a function. Function is going to greet. So I can have this name. So I can have a use case where I'm not sure whether it's going to be a name or a number or some other thing. So I can give this name to be of type any. So when I console log, say this person, so let me say hello. Hello name. And out here, I call my function, let me say greet. So here I can pass in any type. So I can pass in a string, so pass in a number, any type, any type I used, I can pass in any value I want. So you can see I passed in John as a string, I also passed in 89 as a number. So when I go to my console, I'll be able to see hello John and hello 89. So that's the any type. So it can be used for use cases where you're not sure of the input you're going to receive. So you can use it in that way. So we also have the unknown. The unknown So the unknown type, it is a type-safe counterpart of the any. This one requires you to perform a type check before using the variable, unlike the any. So this one will prevent runtime errors by forcing you to narrow down the type of the variable before using it in your code. So to illustrate the any, the unknown, we're going to use the same function that greets choose another greet me. So we pass in name. I'm going to give a type of unknown. So yeah, we said you first check type of name string and console log hello. Come here and call our function greet me, and we pass in a string, let's say John, and another case we pass in the previous case. So when you come to our console, it will tell us hello 89 and hello. So they will only return hello John. 89, it will have no output, since we had this check that expected type of this should be a string. So that's the difference between unknown and any. So let's see our next. So our next is going to be the TypeScript aliases. So this is aliases. So the TypeScript alias is simply a name of any type you can actually use a type li to give a name to type of all and not just an object type. So we can say that type email is equal to string and it's going to be of length 10. Yeah, of length 10. So you can make use of this when it comes to form validations. You can also say type id, which is going to be a number a string. So when you're expecting id to be of either type number or string, you can define it like that. So you say type is going to be data is going to be an array of number and a string. So this is simply how we define a type alias to give a name to any type, which may not be an object specifically. So you can simply do it like that. So let's go to our next. The next is interface. So interface is also similar to type. Interfaces. So TypeScript interfaces are similar to TypeScript type. Let me take you back to this object type. So the same here we had a type. So here we have this type and we named it the cap properties. So you can also do the same thing using interface. Let me use this very example. Let me copy it and paste it here. So here you can say interface. It's supposed to have small I. Yeah, make it small I. Interface. Then interfaces always it's advisable to use that I before. So for interface, you don't need this equal. So this is it, interface. So I've named my interface to be car props, and these are the types it's taking in. So I can still have my same object. Let me say const my 2. So I have const 2, which is going to be an object. Let's take text in type, which is going to be, let me say, it's a Land Cruiser. Then the price to be $2,000, and the year of manufacture, year of it, year of manufacture to be a number, to be 2004. So one thing I forgot about to talk about in while using the type is that you can also come here and say, you can say like year of manufacture is not required, so you do that with placing a question mark right there. So even if you don't use it here, TypeScript will not require you to use it, since you have defined that year of manufacture is not that required. So this is the interface. For the interface, you can extend some properties of it in another interface. So let's say I have this interface. Let's say I have interface. I call it I cap props. This one unique. I calls props. So what I can do is called extending interfaces. So I can extend these properties to my new interface. I can simply do that by saying this icap props and come here and extend, and say it extends the properties of icap props. See, I already have them here of icap props. So what I have simply done here, I've simply wrote these props. I include them in this new interface. Then some other thing. Let me say I have and this brand will be, let me say, data. So I've simply extended these props I have here and added some new property. So that's how interface works. It can simply extend properties of another interface. The type, for the types, it cannot be done to go on and make another structure of that type. You cannot extend types of another type to the new type you are trying to create. But the interesting part of interface, you can also extend the type. Let me say I have these cap props, so I can also extend this type to this interface. So I can say that it extends props. So what it will do, it will come and get these properties of the cap props and extends them to my new icap props. So that was it for this. So we go to casting. TypeScript casting, we're going to simply be talking about so there are some times when working with type where it is necessary to override the type of the variable, such as when incorrect type are provided by a library, so their casting can come in. So I can simply illustrate this with, let me say, I have a variable x that is of type unknown, and let me assign it to a string hello. So I can come and console log x as a string, in brackets. So I can console string x as string length, yeah. Okay, casting with a straightforward way to cast a variable is using the keyword which will directly change the type of a given variable. So casting does not actually change the type of the data with the variable. It actually maintains that data as expected, since a variable x is holding an unknown type. So even if you use a number, it will simply print undefined, since the number does not have a length. So that's how I can simply explain casting. So let's jump to TypeScript guides. TypeScript guides are special checks you can perform on a variable to narrow down its possibility types with a specific block of code. Illustrate this with this example. Type alphanumeric. Let me call this alphanumeric. Alphanumeric, which is going to be a string or it is a string or a number. So I went on and pasted this function. So this function, I said that I came here and defined the types. I said alphanumeric is going to be of either type string or type number. So inside my function add, I've passed in parameters a and b. So a is expected to be of type string or a number, and as well as b. So I came and did this if, where I checked the type of the number and the type of a and type of b. So I said if type of a is number and type of b is number, go on and return the sum. then I also come and say that if the type of A is a string and the type of B is a string, go on and concatenate the two variables. Then for the else part, I'm gonna did this error. So in case A is a number and B is a string, so this will show up. So when you return A as a number and B as, when you call this function and it has the arguments as according to these if statements, results will be as you defined above. So let's think of guards as like filters that enable us to understand variable types based on some conditions. This one allows us to access properties and methods that wouldn't be available on the wider specific type. Built-in type guards, this one enable us, the built-in type guards are the type of operator. So this ones enable us to check the type of the variables against basic types like strings, numbers, and we also have the in, how do I call it? For instance, operator. It's also built in guard. Okay, yeah, I think that's all for the guards. That's how we can use them. So thank you for following up to this point. I think this marks the end of the basics of TypeScript. So in our project, in our next lesson, we are going to try to apply them in the real life applications and we see how we are able to write the JavaScript our app. So in these two lessons, we have been going through the syntax, the different cases. So thanks for watching up to this point. Thank you very much. Let's meet in next lesson where we shall be exploring more about Next.js with TypeScript. Thank you.